Hello there, it's Machine Learning Prospects and Applications 2015, Berlin, Yandex.
Machine learning came to another stage of evolution. Very popular experimental engineering analysis, what we have in our community, is deep learning.
There's similarity control and knowledge transfer, but there is a trick number 3, is synergy. But how many different tricks we don't know. Synergy everywhere, but we use different kernels, different technicalities. And we got synergy for that. I'm sure, absolutely sure, that these 3 tricks, which we call intelligent learning, is just beginning.
I'm sure that from Vapnik's bush of ideas, we will find a chance to improve theoretical base for deep learning. It is my personal view.
Protein structure prediction is a fundamental problem in computational biology, and it is not solved. Okay. The training data comes from the Protein Data Bank, which is the main public repository of solved protein structures. These have been solved experimentally with methods like X-ray crystallography and X-ray diffraction. And so we're using machine learning methods, among other things, to try to learn how to go from the sequence to the X, Y, Z coordinates of all the atoms in the structure.
So if you can't come up with a mechanistic model or with some analytic or explicit model, then you need a data-driven model, and that's what machine learning is built for. I think many of these problems that have this are of this kind of nature you find in biology and medicine. So we're interested in analyzing data from the brain, and we're also interested in some applications related to that. So we're working on brain-computer interfacing.
In a sense, I'd like to become the glucometer of the brain, to determine, okay, what's going on. The emotional part of the brain is actually distracting this person from making any logical decision. And then later there will be this connection of brains and computers, better connection that will help when there's a problem in one of the channels of communication, say between the brain and the limbs.
If you want to have a real conversation like on Star Trek, where you forget that someone speaks a different language than you do, you need to have translations that happen instantaneously. And you can't have instantaneous translations if you have, say, a verb at the end of one language and it needs to come in the middle. And so the way that this can help education is by forming close interpersonal connections when you have conversations that seem like they're happening instantaneously.
So what is the future direction to go? It's called MINDS, M-I-N-D-S. M stands for machine translation, I stands for information retrieval, N stands for natural language processing, D stands for document processing, S stands for speech recognition and understanding.
Data scientist is a combination of math, computer science, programming, and applications of machine learning, like get some experience solving some problems. You can use open source tools which are already polished enough to solve a lot of problems, and you can do that well. But to do that extremely well and to apply that to new problems which were not solved before you have to really understand the math behind it. So my recommendation is that first you should know your math. More specifically, of course, probability theory and statistics.
That language is different is that language is connected between the words. So it's in science, each of the experiments are mostly independent. That you see one experiment after another doesn't mean anything, but if you see Russian, then federation after another, that changes what federation means instead of talking about, say, football.